Hello everyone. So let's learn light reflexes and accommodation reflexes in this video. So coming to our practicals. So I would like to dig in a bit of our practical knowledge before starting this video. So all the first year MBBS students, so we would have done light reflexes and accommodation reflexes in our physiology practicals, right? So what do we actually do in this? Take a pen torch, project the light directly into one eye and look for pupillary constriction in the other eye. Once we see the constriction, we just report or tell the observation. But have you ever wondered why is this happening? Like if you pinch your left hand, why is it paining on your right hand, right? So, I mean, just an example, but we have our physiology to help us find out why. So, let's see. So, firstly, light reflexes are nothing but when light is focused on one eye, the pupils of both eye constrict, and this is called as light reflexes. So, what happens when you throw light on one eye? It passes through the optic nerve, like the stimulus or the impulse. It reaches through the optic tract, and from there it goes to the pretactile nucleus in our brain and also the superior collicula of the brain. For the knowledge on this, we need to know our neuroanatomy well. So, the light reflex is the one happening in the eye on which you're putting the light or you're throwing the light directly. So, what happens on the eye where you throw the light? So, the Edinger-Westphal nucleus receives the impulse from the pretactile and the superior colliculi. So, from there, through the optic nerve, it reaches to the ciliary ganglion. From there, through the short ciliary nerves, it reaches to spinchita pupillae, and from there, it does pupillary constriction. So this is something happening on the eye or in the eye where we are throwing our light. So the other eye where you're going to look for the pupillary constriction, what is going on over there? This is the only change, that is activation of contralateral Edinger-Westphal nucleus. So the contralateral part of Edinger-Westphal nucleus is going to be activated, and it's going to take the same pathway that is going on in the eye where you project the light. And even on the other eye where you don't project the light, it is showing pupillary constriction. So the consensual light reflex is the one which is taking place in the other eye where you don't throw the light but check for the pupillary constriction, right? So let's dive into a bit of anatomy. So you can see in the flow chart, so this is our oculomotor nerve. So from here it goes to the ciliary ganglion. This is the ciliary ganglion. So from the ciliary ganglion, where is it going? To the short ciliary nerves. So through the short ciliary nerves, it goes to the spinchita pupillae over here, and then it enters or it does pupillary constriction of the eye and also the other eye. So that is what is happening behind the pupillary constriction. So that was about light reflexes. So coming to accommodation reflex. So what is accommodation reflex? Pupils of both eye constrict on looking at near object. So that is called accommodation reflex. So in this, we instruct our subject to look at a far vision, and as soon as we bring our index finger, we ask them to focus on the tip of the finger. We ask them to focus at the tip of our finger, right? So the gaze shifts from far object to the near object when the subject points at the tip of our finger. So this through the visual pathway enters the visual cortex. Visual pathway we have studied in special senses. So visual cortex area number 17, where is it exactly in our brain? So let's say this is our cortex. So the area number 17 comes at this region, 17, 18 and 19. So there, so as I showed you in the diagram, area number 17. So this is the occipital part. Remember occipital mesencephalic pathway. Through this pathway it enters the Edinger-Westphal nucleus. From there, as usual, we have seen in the light reflex also, it goes to the oculomotor nerve, and then contraction of ciliary muscles, spinchita pupillae, and medial rectus muscle is responsible for the movement of eyeballs over there, and it increases convexity of lens constriction of pupils takes place, medial rotation of eyeball also takes place. So that is the mechanism behind accommodation reflex. So that was accommodation reflex and also light reflex. So thank you for watching. Hope you enjoyed. Follow Ardent Medical Sub for more videos.